Networks work best when traffic knows where it belongs. Without clear boundaries, performance and security can suffer. Virtual Local Area Network, VLANs, are one of the simplest ways to create those boundaries. VLANs are separate mini networks inside one physical network. This separation helps you keep your network traffic organized, boost security, and can even improve performance. When normal VLANs are created, you assign them any number, from 2 to 1001. On a Catalyst 1300 switch, you can also assign the VLAN names for easy identification. Because of all these options, an existing VLAN on one network most likely won't match up with those on another. If you're a business owner juggling multiple offices or departments, one-to-one VLAN mapping is a handy tool to keep things running smoothly. Imagine you have two offices connected through a service provider's network. Both use VLAN 10 for their internal devices. In one office, VLAN 10 is for accounting. In the other, VLAN 10 is for a guest network. You definitely don't want your accounting data mixed with your guest traffic. One-to-one VLAN mapping makes sure these VLANs stay separate and secure, even though they share the same VLAN ID locally. In this episode of Cisco Tech Talk, I'll explain the basics of one-to-one VLAN mapping, available on Cisco small business switches. Next. With one-to-one VLAN mapping, each VLAN from one side of a network is mapped directly to a different VLAN on the other side. Here's how it works behind the scenes. When data enters your network, it is tagged with a VLAN ID. This VLAN ID is called the Customer VLAN or C-VLAN. As the data passes through the switch, the C-VLAN is translated to another VLAN ID called the Service VLAN or S-VLAN. The Service VLAN, S-VLAN, is a VLAN identifier used primarily within a service provider's network. It acts as a second VLAN tag that encapsulates the original Customer VLAN, C-VLAN tag. This lets the provider isolate multiple customers' traffic, even if they use overlapping VLAN IDs on their local networks. When the data leaves the switch, the VLAN ID is translated back to the original one. With one-to-one VLAN mapping, you can manage VLANs locally while the service providers manage their VLANs separately. Overall, it lets your network devices behave as if they're on the same local network, even if the traffic passes through a service provider's infrastructure. This process is automatic and transparent to your devices. A few general notes to keep in mind. One-to-one VLAN mapping is usually configured on switches that connect your network to a service provider or another network segment. It requires setting which customer VLANs map to which service VLANs. The switch ports involved are typically set as trunk ports, which means they carry traffic for multiple VLANs. Untagged frames or VLANs with VLANs IDs not specified in the mapping are usually dropped to prevent unauthorized traffic. The switch uses special memory, TCAM, to handle VLAN mapping rules. TCAM is a special high-speed memory used by the switch to store VLAN mapping rules and other network policies. Each VLAN mapping may consume multiple TCAM entries. If you have many mappings, ensure your switch supports the required resources. On a Catalyst 1300 switch, you can reserve up to 228 VLAN mapping entries. One last note. For some switches, including the Catalyst 1300, spanning tree protocol needs to be disabled on these ports to avoid network loops in VLAN mapping scenarios. There you have it, a quick look at how one-to-one VLAN mapping works. Setting this up helps you avoid any mix-up with VLAN IDs, keeps your network traffic separate, and helps communication flow smoothly. If you're ready to try this out on your Catalyst 1300 switch, click the link in the description to get started. Thanks for watching. I'll see you next time.